Welcome to the Topic 1 Study Guide. Please look at the attached PDF that is attached to this assignment, and in order to study efficiently and effectively, look over everything, try the problems, and then watch the following video hopefully that will answer any questions that you might have or fill in any gaps that you might have in your learning. Pause, start, and then I'll see you in a few minutes. Topic 1. Some important vocabulary that you need to know. I'm going to discuss some things through a slide right now that I have planned out for you. So let me get started at the beginning. One of the first things on there is a conditional distribution. So you can check this off as you go along, and I'm going to kind of jump around a little bit. But a conditional distribution is where you have two different variables. It's one variable on the condition of the other. I'm going to use my highlighter here, and I'm going to show you the conditional part. So this column right here is the distribution of eye color that is conditional on if it's a female or a male, okay? Here's part of a conditional distribution as well. The eye color brown, dependent on if they're a male or female. And you can look at that the other way around as well. So if I would undo what I just did, and now if I would highlight this row here, male, okay? This is the distribution of eye colors based on if it's a male, okay? On the condition that we have a male. In pink, this is the condition of eye color, right? Or it's the distribution, excuse me, of eye color based on the condition that the person's female. Now, you use this a lot in probability, and we'll get into this a lot more when I go through topic 3, the probability section. What I do want to discuss, oops, sorry about that. What I do want to discuss is what a marginal distribution is, and I already have that highlighted for you. What I have highlighted in yellow is the distribution of eye color. It's not dependent on any gender or any other variable. So I'm just looking at the totals of the eye color, blue, brown, green, and other, okay? If I would highlight, I don't know what's going on with my computer, seems to be common with me. If I'd highlight the totals of gender, now this is the marginal distribution of gender. I have 43 total males, 37 total females, which is a grand total of 80. So that covers a marginal and conditional distribution. If you have any other questions at this time, please write it down and let me know as soon as you can. Furthermore, if you're still kind of curious about it, make sure you watch the topic 3 video, and I'll cover more about that there. The next slide I have is I have the difference between a bar graph and a histogram. Okay, the big thing is with the bar graph, you'll notice that there are spaces or gaps in between each category. And the categories below are categorical variables. So that gives us the definition of a categorical variable. This is where people are from, what country they are from: China, USA, France, UK, or India. Now over here, you could look at this as the ages of people in a room. There's 30 people between the ages of 10 and 20. And this bar actually only fills up the ages right in here of 10 to 19. The 20-year-olds fit in this bar here. So there's 50 people between 20 and 29. There's 80 people between 30, so the 30-year-olds go in this bar, and 39 years old. And you keep going. There's 35 people between the ages of 40 and 49 years old. And then finally, there's 25 people between the ages of 50, and we'll assume that that label there is 60. Okay, so 25, there are 25 people between the ages of 50 and 59, because 60 would go in the next bar or bin. So the bin width there is 10. With the categories, it's important to know that anytime you have a categorical variable, you're not going to be able to do statistical operations with them, like finding the average. I wouldn't say on average people are from the USA. You can't add up USA plus France plus UK plus India plus China. You can find the total number of people from the USA or the percentage of people from the USA, but you're not going to be adding USA and dividing it by 5 like you would an average, where you'd add up the average ages and divide by the total number of people there are. Categorical variable, bar chart. Quantitative variable. Quantitative variables will be your age, your height, your weight, your GPA, okay? The salary that you make. We can find the average salary of all Armstrong High School teachers. At this time, write down any questions that you might have on a bar chart versus, or a bar graph versus a histogram. Again, a bar graph is for categorical variables. A histogram is for quantitative variables. The biggest thing you have to remember, an AP free response question is out of 4 points. Do not lose an automatic 1 point for not labeling your graphs. The next thing I want to talk about are these distributions. The center graph right here. This is what we call a symmetric unimodal distribution. On the AP exam, you just have to say symmetric. That's completely fine. This is also symmetric, this red graph over here. But what's important about it is it's what we call uniform. Again, for most things that I've seen on the AP exam, saying it's symmetric is just fine. I'm just trying to cover my basis for you guys in case the word uniform would pop up. We don't talk a lot about it in AP stats. And this graph right here, I would say, would be mostly uniform. If you can draw a curve around it and it looks almost like a rectangle, it's mostly uniform. Write down any questions that you might have about a uniform distribution versus a symmetric distribution. It is important to remember that in symmetric distributions, no matter if it's a curve or uniform like the rectangles, the mean and the median are equal or approximately equal. And now we have a skewed distribution. The blue graph, the tail is on the right-hand side. So we have a skewed distribution that is skewed to the right. Over here in the red graph, the tail's on the left-hand side. So we say the distribution is skewed to the left. It is important to remember, and this is very important, that the mean is affected by outliers. That means the mean is not resistant to outliers. That was another thing on your chart. The mean is not resistant to outliers, but the median is resistant to outliers. If you're going to interpret the median, you're going to say 50% of the observations are equal to or less than whatever the median score is. Since we just talked about the mean being affected by outliers, it is important to note that in a skewed right distribution, the mean is greater than the median. And then again, in a skewed left distribution, the mean is less than the median. That definitely I could see as being some sort of question, or you need to apply this knowledge to some sort of question on the AP exam. Here I have a stem and leaf plot, or in AP stats it's known as a stem plot. There are some advantages to a stem plot. When you have a small sample size, it's easy to graph a stem plot. Please note that I have a key with a stem plot. 8/0 means 80. An advantage of a stem plot is you can see the actual numbers versus a histogram. If we go back and look at this histogram, we don't know the actual numbers here. We just know the count between the interval. So for example, this middle bar here, I don't know how many people are 31 in this bar or how many people are 32 in this bar. I only know that there's 80 people between 30 and 39. Whereas in a stem plot, I see the exact numbers. Again, it's important to note that you really only use this when you are dealing with a small sample size. You can see back-to-back stem plots, and if you see a back-to-back stem plot, it could be maybe on the right-hand side, it would be store A, and then on the left-hand side over here, it would be store B, and they would have a line drawn down here. And then they would have the numbers going this way. So they might have 2, and then they'll have 5, and so on. Okay? You may have questions about comparing here, comparing the stem plots. I have seen that before. Look at the shape. Now, if the shape looks like this over on store B, let's just play pretend. This one, and let me point the arrow, store A, if I point to it, the tail, give me a second, I'm moving my mouse. The tail's right here because of that extreme observation. Some people might call it symmetric if there wasn't an outlier. I'm going to go with there's a skewed distribution with that outlier there. And then I might say if you took the outlier away, it's symmetric. Nevertheless, if I look over here and I drew the same curve, this one is skewed to the right. And then this one right here is actually skewed. People are going to want to say it's skewed to the right, but it's also, people are going to want to say it's skewed to the left because they're going to tilt their head, but this one's also skewed to the right. I'll try to find some practice ones for you so you can look at that and make sure you can tell on a back-to-back which way it's skewed. If you're confused about this, pause this and make sure you make a note to yourself to ask me in class. Next, I have a cumulative relative frequency table. I actually have a few different things going on here. So first of all, a frequency table, let me highlight, is just right here. I'm looking at different ages and I'm counting the frequency. And I wrote down 44 there because there's 44 total presidents when they were inaugurated. Next, in this rectangle, I have the relative frequency. Okay, so I'm just taking the count and dividing it by 44 because that's my total sample there. Okay. This part here is what we call the cumulative frequency. The cumulative frequency right here, we have 2, 9, 22, 34. Please look and see, okay, the first one I have 2 presidents between 40 and 44. That will stay 2 for the cumulative frequency. Now I have 7 presidents that were between 45 to 49. Well, cumulatively, when I take the 7 and the 2, there's a total of 9 presidents that are under 49. It's taking the 2 plus 7, and that gets us 9. Next, you can see from 50 to 54, we have 13 presidents that were inaugurated. You take that 13 plus that 9, and that gives you 22 total presidents that were on 54 or under that when they were inaugurated. And over here, you can see the cumulative relative. So you're just taking that number and dividing it by 44. So this 50% means 50% of the presidents inaugurated were 54 or under that age. Take a second, write down some notes if you have any questions. Here's actually a cumulative relative frequency graph. So it's plotted out, and the question is, was Barack Obama, who was inaugurated at age 47, unusually young? Okay, well, 47 is your age right there. You go to the percentage, which is 11, so that puts him in the 11th percentile. I don't think anything's super unusual until it's below 5%, like our significance level. Look that over and make sure you understand the question and how to read the graph. Make sure you also know how to read it backwards. Okay, so if I said, what age? Okay, so I'll type it out. What age would put a president in the 80th percentile? Okay, going backwards, I'm going to hit 80 here. That brings me to about here, and then I'm going to go down, and I'm at approximately 60 years old. So if I'm 60 when I'm inaugurated for president and being in the 80th percentile, that means 80% of presidents at inauguration day were 60 or less than that. Here's a cumulative frequency graph. So this one's not dealing with percentiles. This is dealing with actual counts. So if you look at this here, you can say, okay, from 10 to 11 years old, I'm going to go up to 11, and I'm going to say, hey, there's a frequency of approximately 18. From 11 to 12, there's a cumulative frequency of approximately 40, 41. If you look here at the difference, that means that there's only about 22-ish people from 11 to 12 years old, And then we said there was 18-ish people from 10 to 11 years old, giving us a total frequency of 40. You could do it again. You could say, okay, at 13 years old, at 13 years old, there's a total cumulative frequency of 60. Okay, so there's 60 people that are 13 years old or under that. But between the ages of 12 and 13 right here, there are a total of, well, from 40 to 60, right? So we go from 40 to 60. That's, oh no, forgive me. From 40 to 60, that's 20. Okay, so there's 20 people from 12 to 13. So you can keep doing that if you're trying to figure out the actual counts of the individuals in that interval. Here, this graph I have is just making sure you remember how to get one variable stats. Okay, so this is the one variable stats of the test scores, I believe, but I'll have to double check that for you. The only reason I have this slide is to make sure you know how to type things into L1, you know how to run your one variable stats. So you can practice this, and I just quick grabbed this from the internet and was made a foolish mistake not to actually test it out to see if it was the homework scores in here or the test scores, but either way you can practice that and see, and I can let you know in class tomorrow.